Alright, we're ready for section 2, which talks about electricity and magnetism. So, Hans Christian Ørsted was a Danish physics teacher in 1820, and he found that electricity and magnetism are related. So at this time period, they said, okay, we have electricity, we have magnetism. They're two totally separate things. We don't think they're together. And so basically, what he said is that, if you have an electric current, then we have this, you have electricity in a circuit. Then when you have electricity, that there must be a magnetic field also around that wire when you have an electric current. And then while that's going on, he said that if you change the direction of the current, it also changes the direction of the field. This is what he hypothesized. Of course, you're thinking at the time that, they didn't know anything about anything, that this is just totally what's coming out of the blue. So, with some investigation, basically this is what they found, that moving charges do produce moving magnetic fields. And so moving charges, of course, are electric currents. So electric currents do produce magnetic fields. And I have a little drawing down here showing that if you have an electric current going down this particular wire, that it does produce a magnetic field, meaning a circular magnetic field going around this particular current-carrying wire. So for a current-carrying wire, the lines form circles. It also, the direction reverses when the current reverses. So I show a picture down here as well, that if we go the opposite way with the particular current, that notice that, look at the arrows. We went one way the first time, that look at the arrows, that they go the other way the second time. The other thing they also found out is that the strength of the particular current increases as well. So, or the strength of the magnetic field. So if you increase the current, you also increase the magnetic field as well. So those were all things that they found. So they found out that Hans Christian Ørsted was correct in his hypothesis. So for a current carrying wire, the magnetic field can be made stronger by changing the particular shape of the wire. So the current inside the loop can be made stronger than a particular straight wire. So before we showed a completely straight wire, so they found that you can have, if you bend the particular wire, that we can make this magnetic field even stronger. And then they found that, what if we actually wrap this wire, we can make the magnetic field even stronger. And so they called this wrapped wire a solenoid. And a solenoid is just a single wire wrapped into a cylindrical wire coil. And so they found that it's just a lot stronger than even a particular straight wire in itself. Now this led into studying more about electromagnetic force. This includes electric force and magnetic force. The attractive or repulsive force between electric charges and magnets. So starting the investigation obviously between electricity and magnetism. So electromagnetism, the interaction between electric charges and magnets. What makes magnets basically so useful? You have a lot to do with this and you don't even know it. Every day you use electromagnetism. We use MP3 players, motors, basically anything that produces, transmits, and uses electricity. Uses electromagnetism, uses electricity, and then has some kind of magnet in it that requires it to work. An electromagnet is a temporary magnet created when there is a current carrying wire. It's used a lot in motors, so basically anything that requires some kind of motor, temporary generator, something like that. It's temporary because it only works when there's current flowing in the solenoid. We have one end as a north pole and one end as a south pole. So if you place it in a magnetic field, it will line itself just like a compass. It will attract or repel each other with just like magnetic materials. Now, the best way I think to understand a lot of like electromagnets is that we build them. And so when we get to that point, or if we've already gotten to that point, depending on when you're doing these notes, we'll actually build these. And so I think see an electromagnet, I mean, you're exposed to them a lot, but of course you can't take your iPods and stuff like that apart to see, hey, here's an electromagnet or whatever, but we build real basic ones so you can see it. So, how can we make an electromagnet even stronger? We can wrap our current carrying wire around an iron core. We can increase the magnetic field of our current carrying wire more than 1,000 times if we wrap it around some kind of piece of iron. We can add more turns to our wire. We can increase the current of our wire. So all three of these things are ways that we can increase or make our electromagnetic stronger. We can do all three, of course. So again, if we haven't got to this lab yet, think about doing all three of these things when I say, hey, make your electromagnet stronger. Galvanometer. This is a device that we use to measure electric current. So simply, if you want to see how strong the electric current is in your electromagnet, there you go. Okay, so a motor is a device that changes electrical energy into mechanical energy. Almost every appliance basically uses an electric motor. So, practical application of our electromagnet. Here's some basic parts of a very simple electric motor. Of course, you can get into sophisticated. You basically have some kind of wire coil. You can see here you have your wire coil. You have some kind of permanent magnet, some kind of thing like this. You have a source of electric current. So there's your source, such as a battery. Okay, and so of course the battery is what produces that. You have brushes that hold, that put that current going. You have a commutator. Okay, the brushes are what makes contact with the commutator, which is the conducting metal ring that splits, and basically gives the electric current to the wire coil. And this is, of course, your, this whole part here is basically your electromagnet. So that's the general gist of section 2.